Section 2B has a lot going on in it. So in the video, I'm just going to talk about piecewise functions, and then we'll save everything else for when we meet together in class. So piecewise functions are something that you encounter all the time in regular life without ever realizing that they're going on behind the scenes. So this happens every time you're shopping online, and it offers you free shipping once you reach a certain amount. So let's say you're shopping online and you see free shipping over $50. And let's say it's like $8 otherwise. So when you go to your cart and you're ready to check out, the computer uses two different rules to figure out how much you owe based on what value is in your cart. So let's say that you have X dollars in your cart. Okay, so the computer's going to say, okay, your X dollars of merchandise plus your shipping costs, but it's only going to do that if that X dollars is less than $50. Okay, if you're over $50, so if X is bigger than or equal to $50, then it's just going to charge you X dollars of merchandise. Okay, and for the sake of this example, we'll just ignore sales tax for a minute. So this is what a piecewise function is. So when we write these in math, we always put a bracket on them to indicate these are really two parts of one function, one machine. All right, and then we'll give it a name, whatever you want to call it. Okay. So let's get some practice evaluating these functions, and then we'll get some practice graphing them as well. All right, so let's take a look at this beast of a piecewise function. This one has 3 parts to it, and piecewise functions can have as many pieces as they have. This one happens to have 3. All right, and they ask us to evaluate f of 0. So remember, a function only gives you one output for every input. So you're not going to take x equals 0 and plug it into all 3 formulas. You're going to find the right one and just plug it into that one. Okay, so x equals 0. Look at those inequalities on the right-hand side of the function. 0 falls in between -2 and +3. So that means that you're going to use that middle function, x plus 5. So we're going to do 0 plus 5 and get 5. Okay, so your first step is to figure out which formula am I using, and then you plug in. All right, let's see, 3 also falls into the same formula as 0, right? X equals 3, because the middle inequality is the one that has the or equal to 3. The last formula says x has to be bigger than 3. So for 3, we're going to plug into x plus 5 as well. All right, -5, where does that belong? -5 on the number line is less than -2. So we're going to plug that into the function 2x. So I'm going to say 2x, 2 times -5 is -10. Next stop, x equals 7. Let's see, 7 is bigger than 3. So we're going to plug into the formula 10. The formula 10 actually doesn't have any place to put an x, it's just 10. It's a very boring function. Its answer is always 10. So f of 7 is equal to 10. -2. Again, -2 is one of our cutoff values for the function. The inequality with the equal to sign in it is this top one here. So we're going to plug in -2 into the top formula. 2 times x, 2 times -2, and I get -4. And our last one is f of pi. F of pi, I guess there's always room for pi. Pi is 3.14 and a bunch of other numbers, right? So regardless of what pi is, it's bigger than 3. So this one is also in the boring function that says the answer is always 10. F of pi is equal to 10. So now we know how to evaluate piecewise functions. Let's graph a couple. All right, so we're going to graph this slightly simpler piecewise function. F of x equals 1/2 x plus 3 if x is less than 2, and 5 minus x if x is greater than or equal to 2. All right, so I'm going to graph both of those parts of the function as if they're not in a piecewise function. Okay, so I'm going to start off with 1/2 x plus 3, and I'm going to graph y equals 1/2 x plus 3. And I'm doing it in orange because this graph isn't going to be my final answer. It's just going to be a tool to find my final answer. All right, so that's just a line, right? An mx plus b, where my y-intercept is 3. So I'm going to go graph a y-intercept of 3. And then I'm going to use my slope, my rise over run. So 1 and 2, that's going to be up 1 to the right 2. So I'm going to go up 1 tick mark and to the right 2. And then I can keep doing this, you know, up 1 and to the right 2. And you could do more to the left if you wanted to. Down 1 and to the left 2. Okay. And then I'm going to go fill those in with a line. Okay, then we have another line, 5 minus x. Let's see, let's graph that in blue. Y equals 5 minus x. It might be easier to think of that one as negative x plus 5. Okay, so that looks a little bit more like an mx plus b. That one's got a y-intercept of 5, so I'm going to go up here, put my y-intercept at 5, and then my slope is negative 1. So I can think of that as down 1 and to the right 1. I'm going to go down 1 to the right 1, down 1 to the right 1, and plot as many points as you need to feel comfortable. So I need both of those lines for my graph, but I don't want all of those lines. So remember that this function says, hey, f of x is equal to 1/2 x plus 3, but only when x is less than 2. So I'm going to put kind of a phantom number line underneath this graph. This is not part of the graph. This is just a tool to help me figure out what parts of the graph I want to keep and what parts I want to throw away. So think about a number line down there under the graph. X less than 2, if I were to draw that, that would be an open circle at 2, and then less than means I want to shade to the left. So I'm going to come down here and say right below 2, an open circle, and then I would shade this way. Okay, and what that means is that's the half of the graph that I want to keep. So I'm going to take my final answer pen, my black pen, and I'm going to go up to the orange graph at x equals 2, so at 2 comma 4, and I'm going to put that open circle there for less than, not less than or equal to, an open circle here. And then I'm going to keep the half of the paper that's got the orange line below it. So this is the part of the line that I want for my final graph. Okay, I don't want anything that still looks orange, so I'm going to take my eraser and just get rid of it. All right, so let's do the same thing to the blue line. The blue line was 5 minus x. That one should only be there if x is bigger than or equal to 2. So I'm going to do another phantom number line underneath the graph. So bigger than or equal to 2 means filled in at 2 and to the right. Okay, so I'm going to take that filled in blue circle, travel upwards onto the graph to 2 comma 3, and I'm going to keep that point with my final answer pen, and then to the right, because I drew to the right with my number line. Okay, and then I'm going to go back and try to erase everything that's in blue as best I can. And everything you see in black is part of my final answer. Those orange and blue lines below, again, were just a tool to help me to get the right graph. So here's the graph of our function. All right, let's try another one. F of x equals 2x plus 1 if x is less than or equal to -1, and x minus 1 if x is greater than -1. So this is a good time to stop the video and see if you can get the same graph that I get. Orange pen up. We're going to graph y equals 2x plus 1. It's another line. My y-intercept is 1, so I'm going to go up to 1. And my slope is 2, which is 2 over 1. So up 2 and to the right 1. Up 2 and to the right 1. And I'm actually going to plot a few points in the left-hand direction because I'm looking ahead and I see that my cutoff starts at -1 and I don't even have a point plotted there. So remember that 2 over 1 for a slope, I could think of that as -2 over -1. That would still give me a positive slope. So I'm going to go down 2 into the left 1. So down 2 into the left 1, down 2 into the left 1. And then fill in the line. And then let's graph our blue graph. Y equals x minus 1. Another line, my y-intercept is -1. And my slope is 1, which is 1 over 1. I'm going to go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. Again, an important part of this graph happens at -1, so I want to make sure I go a little bit to the left. So I'm also going to go down 1 into the left 1, to stay on this line. So let's chop it up and put it together for a final answer. All right, so grabbing my orange pen, x is less than or equal to -1. That means at -1, down here on my phantom number line, I'm going to do a filled in circle for less than or equal to. Less than means I go to the left. So I'm going to take my final answer pen. I'm going to take -1, go up to the line with a filled in circle. And I'm going to keep the part of that line that goes to the left in the orange direction. So I end up throwing a lot of this one away. Okay, again, grab your eraser and erase everything that isn't in final answer pen. All right, grab the blue pen. Let's figure out where the blue line is supposed to be. X greater than -1. So that means an open circle at -1. Greater than means to the right. So we're actually going to keep a lot of this graph with an open circle. So I'm going to go up to the blue line at x equals -1. That's -1, -2. Final answer pen with an open circle and to the right. And then erase all that blue stuff that's not part of your final answer. Okay, so again, this is our final answer. The orange and blue phantom number lines below are just something to help us. That's it for graphing piecewise functions, and I'll see you in class.